Calculus, Wednesday, November 30th. All right, let me, probably would help if I screen mirrored. All right, so we're talking about finding absolute extrema, right? So the homework was all about finding a relative extrema, right? Right, we do what we did here, right? We make a sign chart with the first derivative. Right, and wherever the first derivative changes sign is where our relative extrema of f, of the original function, will be, okay? So we got that, right? But there's a difference, right? What's the difference between a relative extremum and an absolute extremum? That's the highest peak, right? So there's like a relative maximum, right? So like there are mountains on Earth other than Mount Everest, right? Like K2 or... yeah, Mount Kilimanjaro, right? There are other mountains, right? But there's only one highest mountain. Mount Everest. Okay, same with like valleys, right? So like Death Valley has a very low elevation, right? That's a valley, right? Or like, but there's only one point, right? The Dead Sea. Or if you want to go underwater, the Marianas Trench, right? That's the lowest of the low, okay? That makes sense? Okay, so now the difference when we're finding, so candidates, potential candidates, right? Potential candidates for our absolute extrema are going to be what?
Endpoints and all the...
So all of the relative extrema, right? So the highest point is going to be a mountain, or the lowest valley is going to be a valley, right? So you got to check the candidates are going to be all the relative extrema plus what? Endpoints. You got to test the endpoints, okay? So this little green box. If you want to pink sheet this, you can. It's kind of a lot of writing. Maybe do that on your own time, or you can just look at the green box, okay? So let's continue practicing this. So find the extreme of this function on this interval that they gave us, okay? So what we're gonna do is we're gonna find all of the relative extrema. We're gonna find all of the relative extrema, right? Plug those into F. We're gonna plug those into F. Then we're going to plug the endpoints into F, right? And then we're going to take that list of different values of F, pick the highest and the lowest. That'll be our absolute max and our absolute min, okay? So I did a lot of talking. Let's actually do it. Let's do one example and then go to lunch, okay? Find the extrema of F, okay? So we do what? We got to find the relative extrema. So we're going to do what? Yeah. Sign chart with the first derivative. Okay, so F prime of x equals 2, and then what is that? Minus 2x to the negative 1/3. Okay? We set it equal to what? 0. So we want everywhere where 2 equals 2x to the negative 1/3, or 1 equals x to the negative 1/3, or 1 over the cube root of x equals 1, right? No, just cube root of x equals 1, right? Wait, I'm so confused. It's going to be wherever the cube root of x equals 1. Yeah, right? And then we raise both sides. So the cube root of x equals 1. What numbers is solved? What x is solved this? 1 and negative 1. These are our critical points.
Wait, those negatives negative 1.
Oh, no, you're right. No, it doesn't. Sorry. It's just 1, right?
Yeah. It's a negative from the negative.
Isn't it negative 1/3?
Oh, on the right here? I multiplied both sides by x to the 1/3. Yeah.
So wouldn't it be...
I can multiply both sides by x to the 1/3. Okay? What's your rule? You add the exponents when you multiply with the same base. That gives you x to the 1/3 on the left. The left is x to the 1/3 times 1, so x to the 1/3 equals x to the 0, which is 1. That makes sense?
Yeah.
Then I can cube both sides, I get x equals 1. Yep. So that's our only critical point. Okay, so we can make a sign chart then. Are there any points, right? We got to make sure, we got to set the derivative equal to 0 or what? I didn't do that here. I should have went too fast. Derivative, we have to set the derivative equal to 0 or undefined, right? We didn't have to do that here. Actually, we do have to do that here. So sorry. So 2 minus 2 over x to the 1/3 equals 0. What x is that undefined? right? You can't. So this is a negative exponent. We can't have a 0 in the denominator. So yeah, I kind of bounced around. Sorry about that. I'm making a sign chart, and on the sign chart, I'm putting all the critical points of f, which is all the points where f prime is either 0 or undefined. So that x equals 1 here is the point at which f prime is equal to 0. Okay. Okay. That x equals 0 is all the points at which f prime is undefined. Does that make sense? Okay. Good. Sorry about that. Yeah, I kind of bounced around. So we'll make a sign chart with 0 and 1 on it. Okay. When we plug a value to the left of 0, so let's plug in -1. 2 minus 2 over the cube root of -1, that's going to be positive, right? That's 2 plus 2, right? I gotta stop doing these in my head.
Why are we making a sign chart? Don't we just have to like plug in the zeros into the original?
We have to find the relative extrema. So we gotta plug the relative extrema into f, right? In order to do that, we have to find what the relative extrema actually are.
So we just have the critical points, we're not the extreme.
Yeah, so we have to test to make sure, that's a good point, yeah, we have to make sure they're extrema. Okay, between 0 and 1, if I plug in 1/2, I'm doing this on my calculator now. If I plug in 1/2, I get a negative. And if I plug in like 2, I get a positive, okay? So where are my relative extrema? 0 and 1. So these are both relative extrema. So our candidates so far are x equals 0. X equals on the, what are my other two candidates always? The endpoints. The endpoints. Okay. Now we got to plug all these in. So we have to find f of 0, f of 1, f of -1, and f of 3. Okay. So using my calculator, I'm not going to do this in my head anymore. I'm sorry. So using my calculator, I'm going to find these 4 values real quick. So that's 0. That's -1. That's -5. And that's -0.24. Okay. So this list right here, this gives me, so what's my absolute max then?
0.
Absolute max is going to be 0. Okay. So absolute max . Okay, what's my absolute min? It's going to be -1, -5. All right, come back at 12:45. All right, last one out, please close the door because I am also buying my lunch today. It's already locked. Just close the door, please.
So you don't have it by yourself? No. Because you run into it? Is that why?
No, because I'm probably like, oh my goodness, my palms are sweaty.
My palms are sweaty. Arms still look good.
Okay, Eminem.
What does that say? The last
Negative,
next?
-1, -5.
-5. See, now I feel the pressure to hurry.
No, you're fine. Honestly, the longer you take, the better.
Yeah. he's more than I thought he was.
Yeah.
Like, weirdly. He doesn't do anything.
Except for drugs.
But drugs.
Like, if I knew that, I wouldn't have gone all the way through. Like,
But I don't think,
But,
like, he's, like, I mean, if you really want to pursue him, he'll
No,
stop. He'll stop for you. If you really want to pursue him. Are you okay?
I'm like nervously pacing though.
When was the
Like,
last time you talked to a boy?
we talked from like 12 to 4:15 in the morning today.
Okay, on the road.
Not okay. It's literally like I went to sleep for maybe 2 hours because that's all I had. I woke up. I was like, what the actual heck is happening? Like, what am I gonna do? Because I feel like I don't want him to be like mad. Like if I say like never mind, like not feel like I let him on or something. Because like I low-key did, but that's besides the point. Like I didn't know you were doing
You
this.
didn't lead him on. What? How did you lead him on?
I feel bad.
Why do you feel bad?
Because I don't want to like be mean.
You're not being mean. Like, you're just filling him out. You can fill somebody out. Like you can fill people out. You don't have to like them and then like try to pursue them right away. You have to fill people out first to see if you
Like
like them.
crazy.
Yeah. Okay.
That was absolutely insane. I was like, and then he was like, you can't just be silent after I tell you something like that. I was like, what am I supposed to say?
Wait, let me pull it. No, I'm not gonna be quiet.
Yeah, because he told me, and then I'm just like, I was like, I don't know.
Hey Shadia, how's it going?
Good, how are you?
Did you have a good Thanksgiving?
Yeah. It was different. They're
Do you eat a lot of
expecting-
turkey?
Yeah, I've been plenty of turkey. We're expecting 30 and ended up with 6, so,
People?
yeah,
Ever got sick?
yeah. I mean, my son who was in visiting Marcus, I got sick, so a couple people stayed away for that and others were sick and, it's
Man.
a little change of plans for over the top would be the case, but it was fine.
I need your
No,
hand
that
in
one's
this.
in for you.
I need it so badly right now.
Guys, Tony posted.
Tony posted?
Tony posted a story. Tony's got a match coming up.
Me too.
Yeah, he does.
I'm gonna go down these steps. There any water?
Yeah, water. Yeah, he's our perfect score.
I know.
Oh, but I beat him the first game.
I couldn't. Dude, my dad was like mad at me for chewing my mouth.
Oh,
Yeah, he's lucky. Okay, got back to that.
I think, yeah, we'll go with that. We'll go with luck. He wasn't getting warmed up or just giving me the No. It's not like he's just
Are you here to observe me? I'm kidding.
here.
Ryan's 45. Let's keep going.
That's what it is.
All right. So part C, we got to do what?
Resource. Okay.
Yeah. So we got to find all the relative extrema, right? And then we got to plug those and the endpoints into F, right? So you take the first derivative, set it equal to 0 or undefined, right? Or undefined. Okay, we set it equal to 0 or undefined. I don't think this is ever undefined though, is it?
How do you know if it's ever undefined?
You look for a divide by 0. Look for a divide by 0. Look for like a negative. Look for like you can't have a 0 inside of a logarithm. Can't have a negative inside of the square root. The big thing is divide. Don't divide by 0. This one is definitely. I don't think you can solve this without a calculator, can you? So it's never undefined, but we're gonna have to solve 2 cosine x plus 2 sine 2x with our calculator. What's the all right, so we need to see, we're going to use our calculator, right? Solution to that, first derivative equals 0 is going to be where the first derivative, why is it doing that? Oh, okay. It's going to be where the first derivative intersects the x-axis, right? Oh no, it does it like 12 times.
It's between 0.
Yeah, so good. Don't forget, guys, you only want the zeros that are between 0 and 2 pi, okay? All right, so we can actually go to window. I'm going to make my x min 0. I'll make my x max. I'll make it 2 pi. There you go. So we just need those 4. Gosh. That's pi over 2, right? So pi over 2 is a critical point. $3.665. That's a critical point. 4.712. X equals 5.76. Okay, so those are our critical points. Okay. All right, and so then let's start plugging values in. Okay, so we're just going to start plugging values in between our critical points to make our sign chart, okay? Let's come back at 12:45 next time, please.
Sorry, I thought it was 12:50 because we got out like 12:15.
So it's going to be positive right here. If I plug in a value here, it'll be negative. It'll be positive, it'll be negative, and then positive. Okay, I had it graphed on my calculator, so kind of cheated. Okay, so which one of these four, which are going to be extrema? All of them, right? Because it changes sign of all of them. So we need to plug all four of these in to F, and then what else? Endpoints. Okay. So we have a lot of work to do here. This is like a calculator problem, so. Sorry, I gotta plug them into F. But that's not 0. So f of pi over 2 equals 3. F of 3.665 equals 1.5, negative 1.5. F of 4.712 equals negative 1. I'm doing this with my calculator, guys. F of 5.760 equals negative 1.5. F of 0 equals negative 1. And then F of 2 pi. Whoops, my window needs to be bigger. Negative 1. So we just choose the biggest and smallest values. Where's my absolute max?
Pi over 2.
Pi over 2. So pi over 2, comma 3 is my absolute max. Okay, where's my smallest?
8.665, 5.760.
Yeah, so these two are both my absolute mins. There we go, not too bad, not too bad. Just took a little bit. Okay. So, and then they actually give you the graphs to check. Okay.
Wait, can you go back on?
Let's do do one more of these and then move on to 5.6. So particle moves along a straight line, with disposition function on this interval, okay? So find the minimum and maximum velocity. So we want absolute min and max of the velocity. Right? So we need to find what here? We need to find the derivative of s, right? That gives us, yeah, and the derivative of velocity, okay? So s prime is going to give us the velocity. Okay, so don't make the mistake of finding the min and max position. We want the min and max velocity, okay? So what we're going to do, we're not going to find the critical points of s. We're going to find the critical points of v, okay? So you got to take two derivatives. Okay. So this is the function that we want to find the critical points of, okay? Not s. So we got to do what then? Make a sign chart for which function do we make a sign chart of? The derivative of v, so v prime of t. Okay. I'm going to factor this. Is that factorable? Is it not even factorable?
And the 2 on the end without the t should be a 1.
That should be a 1, you're right, thank you. Whoops, no mistake. So it's just 1 and 1, right?
Yeah.
Cool. So what's my only critical point of v then? 1, yeah, because right, it's a polynomial, so it can't be undefined anywhere. The only place it's 0 is at 1. Okay. What's going to happen though? Here's our critical point. So t equals 3 is our critical point of v, right? Do you notice anything about the multiplicity of that 0 though? It's a critical point. Is it going to be an extremum? Yeah, so let's look at this. Let's make a little sign chart. So here's t equals 3. Sorry. Where am I getting 3 from? Does anyone know where I'm getting 3 from? T equals 1, sorry. Yeah, so if we plug in a value to the left of 1, so we plug in 0, we'll get positive, right? If we plug in like 2, we'll get a positive. Okay? So is 1's a critical point, right? 1's a critical point, but it's not an extremum. Okay, does that make sense? Okay, so we don't actually have to worry about that, okay? So we just have to plug in what then?
0 and 3.
Yeah, 0 and 3. Maybe that's where I got 3 from. Okay, so v, so we're not looking at v prime of 0 and 3, we're looking at v of 0 and v of 3. Okay, so v of 0 is going to be 0, right?
Yep.
V of 3, let's use my calculator. I got 36. Okay. So we just have 2 answers, okay? So the minimum is going to be 0, the maximum is going to be 36. Okay, these are our
So
answers.
where did you get the 3?
So we have to plug in not just the relative extrema of v, but also the endpoints. So 3 came from the endpoints. And then for b, we just repeat the same, but with what? Acceleration, right? So now So v prime is our acceleration, so a of t equals, I'm going to leave it in factored form, or I'm not going to leave it in factored form. Maybe I will.
How come you didn't put 0 on the sign graph?
Because 0 is not a critical point of v prime. 0 is not a critical point of v prime. Okay. If you look at v prime, there is, if you plug in 0, you do not get 0 or undefined out. Okay, so here's our acceleration. A prime of t, I'm just going to take it from up here. So that's a prime of t. We set it equal to 0. Our only critical point is 1. That'll be that'll actually be an extremum. It'll be negative to the left, positive to the right. Okay, so 1 is an absolute. 1 is a relative what? Min? So we have to plug in f of 0, f of 1, since that's our extremum, and f of 3, or I should say a of 3, sorry. Okay, so a of 0 is what? 12? A of 1 is 0, right? Yeah, it's a 0 for both of them. It's kind of weird. And a of 3 is what? That'd be 48, right? The maximum acceleration is 48. The minimum is 0. Are you guys okay with that? Okay. All right, so let's do the 5.5 homework for tomorrow, and then we'll have that mini quiz tomorrow as well. Got a mini quiz tomorrow. 5.5 or 5 mini quiz over 5.1 tomorrow. It's on School G. We'll do 5.5 for tomorrow. Making good pace.
Are we ahead of the times?
Yeah. Thank you.
You gonna do all of it?
Is it pretty thick?
Yeah.
Yeah.
It's like 16 questions, some of them with multiple questions.
Number 14 is like
Rich. I
Ooh,
will
it's true or false. Let's definitely do 14. So let's do 14. Won't make this too repetitive. Let's do 14. What else can we cut out? I want you guys to do that first page for sure, okay? These are pretty good.
Cut up 15.
Yeah. Go fast, like, 56 is so crowded.
I think it's all right.
Let's do 11 and 12. I think that is that good enough? That's not a problem.
So first page, 11, 12, 14.
So we are doing 1, 2, 3, and 4. So circle those. We're gonna do 11 and 12 and 14. Are you guys okay with that?
Yeah.
11, 12, and 14.
1, 2, 3, 4, 11, 12, 14.
Those are the ones we're doing or not?
We are indeed completing. So do
1, 2, 3, 4, 11, 12, 14.
all right. So there you go, Ava and Brooke. Supposed to watch this video, so
Ava and Brooke, they're not here.
yeah, but hopefully they'll watch the video. soon.
Should like
Hopefully,
like say like
we
a
should like say
message.
something crazy to see if they like.
Yeah, and then like ask them when they get back. What do I say?
Hey guys,
What's the opposite of egg?
what's the opposite of egg? Guys, what came first, the chicken or the egg? We'll be like, guys, what do we argue about at the end of class? Did you watch the video? Okay, little video quiz. What do we argue about at the end of class?
Oh, we some of them.
I should do that though. I really should, because usually when I assign videos, no one watches them.
Yeah, I can attest.
I can attest. All right, 5.6. Going on to 5.6. Ooh, I love concavity. Yes. It's actually pretty easy too.
Okay, everything's
Yeah, that's kind of biased.
Yeah.
What?
That
Everything's
you
easy
said it's
for you.
easy.
Yeah, I guess it's true. Everything in the Calc 1 is pretty easy for me.
Okay.
Calc 2 gets harder. Calc 2 gets harder. So. Yeah, you're not taking Calc 2. Nick Busam might. No one else wanted to be like a math major though, did you? Engineering?
Yeah.
Chemistry? Oh, you'll take it too. Have fun. That's going to be a grind. A year from now, 1 year from now, it'll be like 2 a.m. You'll be doing problems with your friends.
Can't wait.
That'll be a good time.
Can't wait.
Rich, I'm still gonna have to
I'll probably be.
All right, definition of concavity. This is pretty easy. It's kind of like, do you guys remember the test for increasing versus decreasing? Right, so a function is increasing if the first derivative is positive. It's decreasing if the first derivative is negative. This is pretty analogous. All right, so this is kind of like the meat of this section right here. I'll just circle it in pink. Right there. Okay, so if f double prime is positive, we say the graph is concave upward. Okay, f double prime means the slope. So let me try to draw a little example of this. Okay, so if you have a graph, let's say, like a parabola, okay? You see this graph, okay? Right? This graph is concave upward everywhere, because if you think about this, let's draw some tangent lines, okay? As you go from left to right, the slopes of your tangent lines, they're always increasing, right? They get steeper and steeper. They get more and more positive as we go from left to right, right? Right, it starts out really negative, and then it gets shallow negative, and then it becomes positive. It's really positive, okay? That's why it's called concave upward, okay? Looks like a bowl, okay? All right, that says that, right, the slopes, right? The slopes are increasing. F prime is increasing, okay? Concave downward's the opposite, okay? If F double prime is negative, then we say it's concave downward, right? It's facing downward. So as we go from left to right, the slopes of our tangent lines get more and more negative. Okay, that's why it's a little bit of graphical understanding. Okay, this is important too. Okay, a point of inflection. A point of inflection is an ordered pair where a graph changes concavity. It's going to be, or a better way of saying this, and this is kind of like an extremum, right? It's going to be where f double prime of x changes sign. Okay. Notice that's a little different from where it equals 0, right? Because, right, it's where f double prime changes sign, not necessarily just where it equals 0, okay? So it can change sign at a 0 or at an undefined point, right? But it's where f double prime changes sign. So where f double prime equals 0 or undefined and changes sign, where the sign is different on both sides, okay? So I want us to make sure we remember that, okay? That's kind of it. Yeah. So we're basically, to determine concavity, we're just going to make sign charts with f double prime. Okay. So determine the open intervals in which each graph is concave upward or downward, okay? So instead of making a sign chart with f prime, we're going to make a sign chart with f double prime. So f prime of x equals 4x cubed minus 12x squared. F double prime of x equals 12x squared minus 24x. I'll factor that because I feel like it. Okay. So the two values, the two possible points of inflection, the two possible, right? They're not necessarily. It's going to be x equals 0 and x equals positive 2, right? Because those are the x's where my f double prime equals 0 or undefined. They both equal 0 there. Okay. So -1, if we plug in a point to the left of 0, we get a negative, right? No, we get a positive.
Plug
We get a
into F
positive.
double prime.
What?
You're plugging into F double prime.
Yeah, this is F double prime. If we plug in 1, we get negative, right? If we plug in 2, we get, or sorry, if we plug in 3, we get a positive again, okay? Okay, so our points of inflection are going to be what? 0 and 2. Okay, those are our points of inflection. We'll circle those. Then what are the intervals on which we're concave upward then? Good job. Yep, we're concave up on negative infinity to 0. Okay. Union what? 2 to positive infinity. We're concave down on where?
0 to 2.
Yep. So that's the answer, right? But to get full points, on the AP exam, i.e. on your test, when you justify your answer, a sign chart doesn't justify it, right? You have to actually write it out in English. So this is why are these our 2 points of inflection? Because what was the definition? F double prime of x. Let's play it safe. We'll say because f of x changes concavity here. That is like the definition of an inflection point. Okay. Okay. And then it's concave up because let's play it safe, because f prime of x is increasing. Wait, concave up means it's increasing, yeah. And it's concave down on 0, 2 because f prime of x is decreasing, right? Yeah.
Why would it be increasing and decreasing, not positive?
I'm talking about f prime. So f double prime, they're the same thing. They're mathematically equivalent. If f double prime is negative, that means f prime is decreasing. Okay, you see, I put the answer I did to play it safe on the AP exam. Okay, I want to go straight off the definition. Okay, mathematicians love definitions. Okay, so I said it's concave upward there because f prime's increasing. I'm going just like straight off the definition, rigorous definition. All right, same thing. That's why I also wrote what I did for points of inflection. Right, I didn't say where f double prime changes sign. I said because f of x changes concavity. Strict definition. Strict definition. Okay, can we do this one? Let's make a sign chart with f double prime. So f prime of x. So f of x, I don't like the quotient rule, so I'm gonna do a little fancy. I'm going to rewrite f that way. F prime of x equals, it's just a chain rule, right? Still just taking derivatives. So I did this, I whipped through this.
When did you 12 to the, or negative 12 times the quantity x squared plus 3 to the negative 3? Like the very first one. Isn't it?
From
to the negative 2 power minus 8.
For the first term?
No, for the f double prime. Like that. Wouldn't it be to the negative 3 power?
U prime. No, I'm using a product rule. I'm doing the product rule of this. U prime v plus u negative 12x times v prime, which is negative.
I thought you were.
No. Well, that's it. So let's combine these into one. So we got to multiply that one on the left. This is a lot of algebra. A lot of algebra that I'm whipping through here. Because I'm not here to teach you algebra. There you go. And it took the entire time to find f double prime. Cool. Yeah, that was a heck of a derivative. Heck of a second derivative. We'll stop there for today. Just 5.5 for next time. 5.1 equals
Can you
tomorrow.
scroll up to the previous problem?
You get the negative 12
Yeah.
squared plus 3 squared.
Yeah.
How does that turn into the product rule?
I rewrote it as this. I rewrote it. I'm sorry. I totally skipped that. I totally skipped that step. I rewrote this as
Yeah, I thought. Okay.
sorry. I kind of did it my own way. What's that?
He knows. X
Rich,
squared plus
they're literally the same thing.
Hey, stop for me. I'll get you the skill builders. I don't know if I have to take them quiz. That's the take home quiz. Oh, the take home quiz.
Are you still recording?
Yeah, it's still recording.
I don't know anything.